This is the final lesson of this unit. It's about the binomial theorem. And so what this really is kind of like a shortcut to help us factor out or to figure out what these expanded binomials would look like. Or a binomial is a polynomial that has two terms. So then if we were to expand it out further, we have this theorem that we can use to kind of help us do it a little bit quicker. So if we take a look here, if we were to expand this out again, x plus 1, so looking at the exponents that are changing, and our terms are going up by 1 each time as well. So again, in my first, to the 0 power, I only have 1 term. To the first power, I have 2 terms. To the second power, I have 3 terms. And they kind of have a symmetric role. So x and y work together. So as you see, this is x to the third, then x squared, then x to the first, and then x to the 0. Whereas y to the third starts here, y squared is here, y to the first, and then again, y to the 0 power. So when x is decreasing, y is increasing. And the sum of the 2 terms always add up. So again, right here, we have, say we look at this one, x plus y to the 5th power. 3 plus 2 is 5. 4 plus 1 is 5. 2 plus 3 is 5. So our exponents are always going to add up to the degree that we have. The coefficients of a binomial expansion are called binomial coefficients. And so we can use the binomial theorem, which again is kind of listed right here. So to help us find our coefficients, we can use this formula right here. Oftentimes, this is denoted as n comma r. And so you'll kind of see what that looks like. So let's say that we had something like 3. So again, if I were to plug in and use this formula, I would say 10c3 equals 10 factorial over 7 factorial, 3 factorial. And then when you cancel this out, again, if I were to break it up, this would be on the top, it would be 10 times 9 times 8 times 7 factorial, and I still have this on the bottom, so I would cancel these out, and I'm just left with 10 times 9 times 8 all over 3 times 2 times 1, which equals 120. So just an example of how you could use this formula to help you determine how many binomial coefficients there are. Okay, and so this kind of leads us into the idea of Pascal's triangle. So if I look at Pascal's triangle, again, he's kind of the famous mathematician who came up with this. And Blaise Pascal, French mathematician. So really how it works is the first and last number in each row is 1. And then the 2 sums, as you can see in these triangles, above it add up to give you your next term. So if I look at, let's see here again, this would be my 0th row, my 1st row, my 2nd row, my 3rd row, my 4th row. So I would say, all right, in my 4th row, I can take my 2nd and 3rd term, 4 plus 6, add them together, and it's going to equal the number in front of it with in my 5th row, which is 10. And, you know, as you keep going, you can see that happens again when you work to get 15 plus 6 is equal to 21. So these work together, so you can take these numbers from Pascal's triangle and use them in your expanded equation. So if we look here again, these were the numbers we looked at, 4 and 6 equals 10. And then again, notice what the exponents are doing for x. In our 4th row, they're adding up to 4 here. 3 plus 1 is 4, 2 plus 2 is 4. In this row, it's 5, so 3 plus 2 is 5. So you can kind of work in a system to be able to get these answers much more quickly. So if we wanted to factor out something, it says use the 7th row of Pascal's triangle to find the binomial efficients. And we want to do this. Basically, going to go all the way there we go. So again, if I look at the 7th row here, some of my coefficients are going to equal, here, let me move this down. Apologize, I gotta just want them to be next to each other. Okay, there we go. So if I were to just look at this, okay, I'm going to take my numbers from my 7th row, that's the bottom row, and just kind of put them in right here. 1, 7, 21, 35, 21. Again, it's going to start decreasing in the same order. And then 1. And then I need to add them. So to go from my 7th row to my 8th row, I always start with a 1. 1 plus 7 is 8. 7 plus 21 is 28. 56, 70, 56, 28, 8, and 1. And you can see that this gives us our corresponding answers. So if I had to find all the coefficients, I could do that.